my name's Tyler. Today I want to talk about Amazon Business Intelligence. What is Amazon? Today it's known as a massive e-commerce enterprise founded in Seattle, Washington. It was founded by Jeff Bezos, CEO, in 1994 as an online bookstore. It's mostly known today for selling goods over the internet through third-party retailers. It changed the game of infrastructure service market through AWS, what we'll talk about later. AWS, or Amazon Web Services, was officially announced in 2006. So what is Amazon? Amazon on the surface. So when I was first approaching this project, I was mostly thinking about the e-commerce side of things. So when you go to buy something online through Amazon, you notice that it remembers what kind of trends or like the products that you buy, and it suggests those kinds of products. And it tries to predict what you will buy next. So that's kind of what I was thinking. However, there's much more to Amazon that meets the eye. More things like Amazon Alexa, Amazon Prime, and Amazon Fire. So let's talk about AWS, or Amazon Web Services. AWS is a subsidiary of Amazon that offers multiple cloud computing services. Amazon had trouble launching new projects and supporting customers. That's what kind of gave way to Amazon Web Services. It was kind of created by accident and out of a need to innovate. So they realized that how big their company was getting, and they needed to innovate to get to where they wanted to be. And what made it so successful was that it was backed by top management. So when they were approaching how to construct Amazon Web Services, they wanted to ask two questions about their organization. So the first couple questions were, what are we doing well, and what are we not doing well? So revelations that came from answering those questions was, some of their findings was they were not accurately assessing how long projects would take to complete, and using too much time to build the same infrastructure over and over again, things like storage and database solutions. Also, partners with Amazon echoed the same complaints, so they weren't the only ones. There was also data warehousing problems. It was expensive, it was hard to manage, and it required too much hardware for scalability. It required large amounts of servers just to do everything that they wanted to through their systems. Also, the infrastructure was intertwined together. They needed to build APIs for external solutions to decouple the platform, and that was just a lot of work. So what came from this, from AWS, was when they were constructing the solution, they realized that there was a completely new opportunity that came from this. So the opportunity they realized was that there was an extreme opportunity in infrastructure service market, and the company enterprises faced similar issues that Amazon did. There were smaller companies that were interested in computing platforms, but they couldn't afford them, and so that was also an untapped market that Amazon could go into. So, what was the approach and the goals that they wanted for AWS? Well, they wanted to offer compute, database, and storage-based solutions. That was an all-in-one system. Users could build applications on the web. Amazon will do all of the heavy lifting, like CRM, ERP, marketing, advertisements, and high-performance computing, etc., things like that. It was meant to be affordable and quick, flexible, and scalable. It promotes innovation and invention rather than spending resources on upgrading and maintenance of the systems. So business companies and startups could also experiment without thinking about possible repercussions. So if you were to go spend money on an expensive data warehouse and you didn't get the results that you wanted to, you lost a lot of money. With Amazon Web Services, it's affordable and you can move things from there. So what were some of the challenges that AWS faced? So one of the things that came up was the recession. So they had a lot of economic adversity. And also during that time, startups weren't being funded, so the service wasn't used as much as they wanted it to be. Since it was such a new thing, there were questions about how well or the viability of the cloud services was, because it was being online and not on a local platform. However, the recession actually was something that helped AWS later. So because it was affordable, companies could go and spend their money in different ways to go through AWS, and none other suppliers could offer that. So I just want to give a couple of examples about Amazon Web Services. This first one that I want to talk about is Amazon DynamoDB. So Amazon basically created a NoSQL database called Amazon DynamoDB, and it was one of the first NoSQL databases that paved the way for NoSQL in general. Relational database management systems could not handle the amount of data, and it caused outages from overloaded databases. So the challenge was that at the beginning, DynamoDB required too many resources and a lot of management. So they came out with DynamoDB 2012. It's basically the upgraded version. And it resides in the cloud, and the users, all you do is the users just request throughput through the database from the cloud. It supports many tools in the cloud. The biggest asset of using NoSQL is it's scalable and has a flexible schema. It can change data structures and run multiple queries. There was also an ability to encrypt the stored data for security purposes, and there was also an introduction in global secondary indexes that allow for databases to be copied. When they're copied, one can be for production and the other for coring that lead to analytics and testing. So what are DynamoDB's pros and cons? It's substantial growth in data storage and processing queries. These are the pros, by the way. Coring process takes 3 to 4 milliseconds. Buyers don't have to worry about hardware. Buyers only pay for storage and throughput. What are the cons? It can only be used in the cloud. Vendors can be uncomfortable using a database in the cloud. That's kind of what we talked about earlier, and lacks an on-premise version. So the other example that I want to talk about is what's called Elastic File System, or EFS. I basically wanted to see how Amazon Web Services worked with big data, and so this is what I found. So Amazon Web Services is a store file system and used for directories, just like a local file system would. Big data analytics are often file focused. That's why this is relevant to big data. And it can grow to petabytes along with delivering low latencies. It's fully managed and easy to set up, and it can either scale up or scale down. What are some of the focus areas for EFS? So it's simple, fully managed, and easily creatable. Integration is seamless with existing tools along with simple pricing. It's elastic, grows and shrinks as data is added and removed, and you pay for the data that is only being used. It's also scalable. Capacity can grow to petabytes, while throughput scales are linear and with the capacity. Low latency is present no matter what the size of the data is. It's also durable and slash availability. Basically, the objects are restored redundantly over across available availability zones, or what they call AZs. Okay, so now we're kind of moving back to what's called machine learning. This is kind of what I was talking about earlier with the e-commerce store, things that it remembers what you buy, things like that. So I kind of wanted to delve deeper into that. So basically what machine learning is you use algorithms created for predictive analytics. So AWS a service that was developed internally by AWS, now being offered to engineers and outside businesses. So basically what they're offering now was developed internally through their own company. It also provides computing power by building applications online without the infrastructure. So what's the process? So basically there's 3 steps to the machine learning. There's building, training, and deployment of models. Basically, what you do is you collect and prepare relevant data, you select an algorithm, you train a model for predictions, for fine-tuning, for optimal accuracy. The model is then integrated into application and you can deploy it through a scalable infrastructure. So what are the requirements? So to do all of this machine learning, it requires higher expertise, access to large amounts of compute structure and storage, and time to experiment for optimization. So this is another application that I wanted to talk about through AWS. So everything that I just told you, this what's called Amazon SageMaker basically does all this for you. So what Amazon SageMaker does is that it strips away the complexities of data modeling for predictive analytics and machine learning. So I just want to talk about the whole build, train, deploy steps. So for build, it's easy ability to make models that connects to training data, which selects and optimizes the best algorithm for the application, and it's easily connected to S3. So S3 is just a storage system through AWS. And you can train the model. Amazon basically carries the infrastructure workload for that and can scale models to petabyte levels. It also fine-tunes the models for the highest possible accuracy. In terms of deploying, it's basically done through auto-scaling clusters through Amazon SageMaker instances across AZs. Basically, it provides built-in testing capabilities for experimenting with models. So this is a video that I just wanted to show you real quick. And let's see here. Just do this real quick. Here we go.
Have you noticed how applications seem to be getting smarter all the time? Websites provide recommendations for new items based on past purchases. You get an alert from your bank if they suspect a fraudulent transaction. And you get emails from your favorite stores when items related to things you typically buy are on sale. All of these things are examples of ways you can use a technology called machine learning. Machine learning algorithms discover patterns in data and construct mathematical models using these patterns. Then, you can use these models to make predictions on new data. Machine learning is something you could use for lots of applications, but learning and implementing the complex algorithms required to build models is difficult and time-consuming. and then deploying and managing the infrastructure to analyze the large data sets required to build accurate models and generate predictions at high scale is expensive and requires continual maintenance to keep it all up and running. What if there was a better way? Introducing Amazon Machine Learning. Amazon Machine Learning is a service that allows you to quickly and easily build smart applications that can perform important functions like fraud detection, demand forecasting, predictive customer support, and click prediction. Amazon Machine Learning uses powerful algorithms to create machine learning models by finding patterns in your existing data and using these patterns to make predictions from new data as it becomes available. For example, you could use Amazon Machine Learning to analyze customer feedback in emails, product reviews, forums, or phone transcripts, and recommend corrective actions to your product or service teams, or connect the customers with customer care specialists. Getting started with Amazon Machine Learning is easy. First, you configure a connection to read your data from Amazon S3, Amazon Redshift, or Amazon RDS. Amazon Machine Learning's visual tools help you preview the data to ensure quality, and the wizards and APIs will guide you through the process of creating machine learning models. Once the models are built, you use Amazon Machine Learning's built-in tools to evaluate and fine-tune them, and then the models are ready to generate predictions. Now your applications can either call the Batch API to get predictions for entire data sets at once, or you can use the Real-Time API to generate predictions on demand. With Amazon Machine Learning, you can create models from large data sets, generate billions of predictions, and serve these predictions in real time and at high throughput. There's no upfront cost, and you pay as you go, so you can start small and scale as your application grows. To learn more about Amazon Machine Learning, visit our website, and you can get your first predictive application up and running today.
So pretty cool there. So what I want to talk about now is what's called deep learning. So this is actually something I found on top of machine learning. So there's actually something that goes beyond that, which is called deep learning. Basically, it's more complex than machine learning, of course, and it's geared toward natural language processing, and it's used to detect fraud or fraudulent orders. That's basically mostly in retail. For this, that would be called Amazon Rekognition for deep learning. This is Amazon's version of it. Basically, it provides various identification through image and video analysis and can identify objects, people, text, scenes, and activities. It handles real-time video and features, things like facial analysis, human tracking, and even celebrity recognition. The service requires no specialty in machine learning and is done through an API. And this is just some of the examples for Amazon Rekognition. You can see Big Papi there being recognized there. And when I first saw this up here, I was just amazed at how much this all can be done through a computer, that a computer can learn this kind of thing. So I just want to ask a couple discussion questions. So what is the future of the cloud with IaaS? Will the cloud become the standard in the infrastructure service market now? And will there ever be a challenger to take on AWS or the AWS cloud? All right, so that's Amazon Business Intelligence. Thank you for your attention.